Hi everyone, welcome back to QASoftware-SDET. In our previous video, we talked about types of software testing at a high level. We learned there are two main categories, functional testing and non-functional testing. Today, we will go deep into functional testing, what it is, why it's important, the different types of functional testing, and some real-world examples you can relate to. By the end of this video, you will have complete clarity on how functional testing works and when to use each type in your projects. So let's get started. Let's begin with the definition. What is functional testing? Functional testing is the type of software testing that verifies whether the software application works as expected based on business requirements and functional specifications. It focuses on what the system does, not how it does it. Simple analogy here is imagine you are testing a vending machine. You insert a coin. After inserting a coin, the end result should be it should accept that coin. And after that, you select a drink. After selecting a drink, it should dispense the correct drink. Functional testing is making sure every feature behaves correctly step by step. Then we'll see key objectives of functional testing. The following are the key objectives of functional testing. Ensure the application meets business requirements. Validate that all features work correctly. Identify defects before the product reaches users. And prevent customer dissatisfaction by catching issues early. Functional testing is critical because if core features don't work, the product fails, no matter how good the performance or design is. Example, imagine an e-commerce website. Users add items to the cart, but when they click checkout, it does nothing. If the website is fast and secure, it's useless because a core feature is broken. Functional testing prevents this by validating every function against requirements. Then we'll see types of functional testing. Now let's dive into the types of functional testing. There are several and you will encounter most of these in real world projects. The first is unit testing. This is usually performed by developers. The purpose of unit testing is in this, individual components or pieces of code gets checked. Example, a function that calculates discounts in a shopping app. Check if it returns the correct value for different inputs. The simple analogy here is like checking each Lego block before assembling the whole structure. Then comes the integration testing. This is performed by QA and developers. The purpose of integration testing is verify that modules work correctly together. Example, the login module passes users data to the dashboard module. Ensure there are no data mismatches or communication failures. Analogy, like checking if all Lego blocks fit together properly. Then comes the system testing. This is performed by QA team. The purpose of system testing is test the entire application as a complete system. Example of system testing is a user goes through the full e-commerce flow, browsing, adding to cart, checkout, and payment. Analogy, like examining the whole Lego castle once it's built. The fourth one is acceptance testing. This is performed by business stakeholders or end users. The purpose of acceptance testing is validate that the software meets business needs before release. Example of acceptance testing is a client tests a food delivery app to ensure it aligns with their requirements before going live. Analogy, like showing the finished Lego castle to the buyer for approval. Fifth one is smoke testing. This is performed by QA team. The purpose of smoke testing is quick check to ensure critical features are working in a new build. Example of smoke testing is, can the app open? Can you log in? Can you place a basic order? Analogy, like turning on a new car to see if the engine starts before a full test drive. The sixth one is sanity testing. This is generally performed by QA. The purpose of sanity testing is focus check of a specific feature or bug fix. Example of sanity testing is, a bug in the payment gateway was fixed. Test only that functionality to confirm it's resolved. Analogy, like checking only the brakes after they have been repaired, instead of inspecting the whole car. The seventh one is regression testing. This is performed by QA team. Generally, we can implement the automation in regression testing. The purpose of regression testing is ensure new changes don't break existing features. Example, after adding a new wishlist feature, check that login, search, cart, and payment still work correct. Analogy, like testing the whole Lego castle again after adding a new block to ensure nothing collapsed. The last one is beta or user acceptance testing. This is generally performed by real users or client-side testers. The purpose of beta testing or user acceptance testing is get feedback from actual users before release. Example, select group of users test a new banking app. They report usability issues or missing features. Analogy, like giving the Lego castle to a child to play with to see if it works in the real world. Now let's see real world example of these testing types on a food delivery app. Unit testing, test the discount calculation function. Verify that taxes are calculated correctly. Integration testing can be implemented like ensure that when a user places an order, the app correctly updates the restaurant system. The delivery module gets the right data. System testing, check the full order flow from login, browse, add to cart, payment, order confirmation. Acceptance testing, the client verifies the app meets business goals like order tracking, restaurant management, etc. Smoke testing can be implemented like quick check. Can a user log in and place a simple order? Regression testing, after adding a coupon code feature, ensure the entire ordering flow still works. This layered approach ensures complete quality coverage. Now we'll see some best practices for functional testing. Here are some best practices for effective functional testing. Understand business requirements clearly before writing test cases. Test both positive and negative scenarios. Use realistic test data that reflects actual user behavior. Prioritize critical workflows first. Keep test cases detailed and reusable for future regression testing. Automate repetitive tests like regression for efficiency. Now we'll see some common mistakes to avoid during functional testing. Many teams make these mistakes when doing functional testing, like only testing happy paths and ignoring edge cases. Example, testing payment only with valid cards, not expired or blocked. Not updating test cases after requirements change. Overlooking integration points which often cause hidden defects. And skipping regression tests after new features are added. To summarize, functional testing ensures that software works as expected and meets business needs. There are multiple types of functional testing like unit, integration, system, acceptance, smoke, sanity, and regression. Each type serves a specific purpose in the development lifecycle. Mastering functional testing is essential for every QA professional before moving to automation. That's it for today's video. If you found this helpful, Like the video, subscribe to QASoftware-SDET and comment below on which type of testing you use most in your projects. In the next video, we'll deep dive into non-functional testing covering performance, security, usability, and more. Thanks for watching and see you in the next one.